Hello, hope you're enjoying science expeditions so far. Welcome to the Wisconsin Energy Institute's Microgrid Mapping activity. Before we get started, I'd just like to say that the only materials you'll need for this activity are a piece of paper and a writing utensil. So with that said, let's get started. My name is Lucas, and I'm a student education and outreach programming assistant for the Wisconsin Energy Institute, which is a cross-disciplinary center for energy research on the UW-Madison campus. Here, over 260 researchers study things from microgrids to biofuels to renewable energy systems. And we also provide several undergraduate and graduate certificate programs for those interested in studying energy. So if you're thinking about college and you're interested in energy, that could be something cool for you to check out. And we're located just north of Camp Randall Stadium on the western end of campus. We want to acknowledge that the land we reside on is the ancestral home of the Ho-Chunk Nation and 11 other First Nations groups residing in present-day Wisconsin. We want to acknowledge their inherent sovereignty and also recognize that these groups are doing some of the most important and leading work in transitioning to clean energy systems today. So we'll kick things off with a little drawing activity exploring where our energy comes from, how it gets transported to our homes, and the changes it goes through on its way to our homes. So I'm going to ask you to draw an outlet on your piece of paper and try and picture what object the electricity travels through before it reaches that outlet, and draw that object with an arrow pointing from it to the outlet. And then you'll repeat this process until you've gone as far back as you can go, trying to envision all the steps of the energy transmission process. And don't worry if you don't know all of these steps or if you don't know any of these steps. That's what we're here to learn, right? So you could think about the structures you can see while traveling in your car as you draw your energy pathway, or you might be able to look out your window right now and see something that can fit into this drawing. And I've gotten you guys started a bit here. So here's my outlet on the right, and then directly connected to that is a service panel. So you guys have probably seen this in the basements of your homes. And here electricity is received from outside and then distributed to all the places in your house that it needs to go. This is also called a fuse box or a circuit breaker panel. And this is where you go if the power goes out and need to reset the circuits. So with that all said, you could pause the video here and take as much time as you need to make your drawing. Awesome. So now that you guys have had time to think about all the steps of the energy transmission process and draw them on a piece of paper, I'm going to show you my drawing, which is an accurate drawing of how this energy pathway works in Wisconsin. Don't get overwhelmed when you see it. We'll go from the outlet all the way back one step at a time. So here I have my outlet connected to the service panel, and then that's connected to a meter. And you guys have probably seen meters on the outside of your homes, and that just basically measures the amount of electricity that comes into your house. Attached to the meter is a transformer. You guys have probably seen this all over your neighborhoods. A transformer is just a big green box that acts as a sort of faucet for electricity. So when you go wash your hands, you don't just bang on a random pipe and let the water spurt out and hope it's the right amount, right? You need a faucet to control the flow of the water so you don't get too much and you don't get too little. Transformer does the exact same thing. It receives lots of energy and then it puts out a constant lower amount of electricity so that it doesn't get dangerous and so that we have exactly the right amount we need to use. These transformers receive electricity via distribution lines, and these are the power lines you guys have seen all over your neighborhoods. They basically transport electricity from one place to another. Specifically, they transport electricity from substations, which is just a kind of a fancy word for a larger transformer. It has the exact same function, except it's way bigger. And we have about 9 of these in the Madison area. Connected to the substation are larger transmission lines that are the same thing as distribution lines, except they're bigger and they're made of this metal lattice structure. And you can find them on the sides of bigger roads, such as highways. These transmission lines carry electricity from a transformer, just a bigger substation, and that transformer is attached to a coal power plant. Coal is our primary source of electricity here in Wisconsin, and at the power plant we burn coal to produce steam. That steam rises and spins a turbine. That turbine is connected to a generator that converts the mechanical energy from the spinning turbine into the electricity that we use. So this is where electricity is produced, but we're going to go even further back in this process and explore where this coal comes from. So coal arrives in Wisconsin via a coal train. We don't have much coal here in Wisconsin, so we have to get it from another state. And that state is usually Wyoming. That's our #1 supplier of coal. And here at Wyoming, there are lots of coal mines where these really cool big trucks carry coal from the mine to the train. So now here we just have our raw coal sitting in the ground waiting for us to extract it and turn it into electricity. This is one of the coolest parts of this presentation, I think, because when you explore where coal comes from, you'll find it comes from prehistoric plants that have been compressed and exposed to thousands and thousands of years of intense heat and pressure. So all the organic materials in those plants condenses into coal. So now there's one step of this process that I haven't shown you guys, and I'd like you to just think about what that might be. Here, the energy is locked in plants, and those plants will eventually become coal. So where do plants get their energy? From the sun, right? Through photosynthesis. So that's a really cool concept, and it's a big takeaway from this presentation. All the electricity that we use in our home ultimately comes from the sun. And that'd be true no matter where we live, no matter what sources we get our electricity from. Solar power comes directly from sunlight. The wind turbines that we sometimes use in Wisconsin rely on wind current patterns that are generated by the sun. Even hydropower and biomass, those all come from the energy that's locked in sunlight.